Hi everyone, in this video I will discuss the introduction to systems of linear equations. So let's begin with the definition. What is systems of linear equations? Basically, the simplest definition is that it is a set of two or more linear equations. Examples are, here we have 2x minus y equals 4 and then y equals 3x minus 7. We can use different variables like letter B, like letter C. We can have also three equations, right? It is a set of two or more linear equations. That means at least two linear equations. Okay. Now, in systems of linear equations, it's very important that we know the what we call solutions. Okay. Basically, what are solutions in systems of linear equations? These are numbers that are correct substitute to the variables in the systems of linear equations. And let me give you an example. Here in this equation, x plus 2y in this system rather, x plus 2y equals 4 and 2x minus y equals 3. The solutions are x equals 2 and y equals 1. Okay, the reason behind that is because if we will replace x and y by 2 and 1 respectively in those two equations, like in the first equation, that will be 4 equals 4, right? In the second equation, that's similar. If we replaced x by 2 and y by 1, then that will be 3 equals 3. So that's why they are called solutions. Now, in systems of linear equations, when we talked about solutions, there are three possible outcomes. Okay? Systems of linear equations can have three possible solutions or possible outcomes. The first is a system can have one unique solution. That means the system is consistent. Like in the previous slide, that is an example that has a one unique solution system. The reason behind it's called one unique solution is because we have one value of x and one value of y. Another possibility is that the system can have infinitely many solutions. That means that the system is dependent. And finally, another possibility is that a system can have no solution, or there's no value of x and y that will satisfy the two equations in two linear equations in a given system. That means it's inconsistent. So the question here is, how will we know if, without solving, how will we know if the system has one unique solution, many solutions, and no solution at all? Well, there are two possibilities. The first is if it's a graph. If it's a graph and you see two lines and they intersect, then the equations are independent and the system is consistent rather. If that's the case, then we will be having a solution that has one unique solution. And the solution is the point of intersection of the two lines. So I'm talking about here, there is a value of x and y there. Remember, that's a point in the Cartesian plane, so there's an x and y there. If there is an intersection, the keyword is intersection, and then, or intersect, there will be one unique solution. The system is what? Independent and consistent. Now, another possibility is that if you draw the lines, or if the lines are parallel, that means there will never be an intersection there. Then the equations are, or the system are independent. The equations are independent and the system is inconsistent. We will be having no solution. There's no solution because there's no point of intersection. Okay? Next, another possibility is that the lines coincide. The key word is coincide. The equations are dependent and the system is consistent. There will be an infinitely many solutions if that happens. So here we're talking about graphs. Another possibility is that what if we see just equations, not graphs? Well, you might be thinking, well, so we will graph those two. Well, what if, we don't know how to graph, or the teacher will tell you, don't graph the two? How will you know if the system has one solution, no solution, or infinitely many solutions without solving, right? So here's the key. just study the table. And as you can see in the first scenario, the slopes are not equal. We're talking about the slopes. So you gotta convert or transform the two equations into y equals mx plus b. And if you see that the slopes are not equal automatically, you don't need to compare the y-intercepts. There will be a one unique solution in that system. Now, in case that the slopes are equal, you gotta compare the y-intercept, okay? So if the slopes are equal and the y-intercept are not, look at that, they're not equal, we will be having, or the system has no solution at all. Another possibility, the third one, is that the slopes are equal and the y-intercepts are also equal. So if that is the case, then there will be, or the system has an infinitely many solutions, or has infinitely many solutions. Okay? Let's go to the examples. I will just give you three. Okay? So what we will do is we will convert or transform each of this into y equals mx plus b and then compare the slope, right? That's what we want, or that's what we will do. Convert this to and compare the slopes and the y-intercept. Y equals mx plus b. Let's begin with the first one. Okay. So I will subtract 2x on both sides. This will be negative 3y equals negative 2x plus 4. You can't combine those two. Next, we want that negative 3 to be not there. We just want y on that side of the equation. So we will divide each term by negative 3. So you can cancel that out. This will be positive 2/3 x. Negative divided by negative is positive. Positive divided by negative is negative 4/3. So here our slope is the numerical coefficient of x. That's 2/3. And then the y-intercept is at 0 and negative 4/3. Okay, that's what we want to know, those two. The slopes and the y-intercept. So the slope and the y-intercept. Let's find the slope and the y-intercept of the second equation. Okay, minus x on both sides. So just cross that out. Divided by 2. Right? Cross that out. Okay, so here our slope is negative 1/2. And our y-intercept is at 0 and 5/2. Now, as you can see, we have m equals 2/3. And the other one is m equals negative 1/2. Which means that the first, or the two slopes rather, are not equal. If you see that, there's no need for you to compare the y-intercepts. We can automatically conclude that the system has one unique solution. There you go. One unique solution. There you go. Okay? So as long as the slopes are not equal, there's no need for us to compare the y-intercepts. Let's go to the next example. Again, we will just, convert or transform the two equations into y equals mx plus b, and then compare the slopes, right? And the y-intercepts as well. If the slopes are equal, we will compare the y-intercepts. So let's do this. We have 3x plus 6y equals 1. So I will subtract 3x on both sides. This will be 6y equals negative 3x plus 1. right? Next is we will divide each term by 6. This will be negative x over 2. Simplify negative 3 over 6. That's negative 1 half plus 1 over 6. So our slope here is negative 1 half. And our y-intercept is at 0 and 1 over 6. For the second equation, okay, subtract x on both sides. So this is 2y equals negative x minus 1, then divided by 2. Y equals negative x over 2 minus 1 half. So we can see that our slope here is negative 1 half, and our y-intercept is at negative 0 and negative 1 half. Okay, now let's compare the slopes. What do you see? That's right. So the two slopes are equal. Now when it comes to, if that's the case, then you gotta compare the y-intercepts, right? Now it's obvious that the y-intercepts are not equal. So if the slopes are equal, the y-intercepts are not equal. Therefore, this system has no solution. Okay? Slopes are equal. The y-intercepts are not. These two lines, if we graph them, definitely there will be parallel lines. There's no solution exist in this system. Okay? Let's go to the last one, last example. Again, the objective is to find the slope and the y-intercept, but we have to convert or transform each equation into y equals mx plus b. Let's begin with the first one. So I am going to add 6x on both sides. This is 2y equals 6x plus 5. Then I will divide 2 on each term. Okay. So therefore our slope here is 3. And our y-intercept is at 0 and 5 over 2. For the second equation, we have minus 12x on both sides. This will be negative 4y equals negative 12x minus 10. Then divided by negative 4. Cross that out. That's 3x. That's positive. Simplify 5 over 2. So the slope of this one is 3. And the y-intercept is at 0 and 5 over 2. Now let's compare the slopes. What do you notice? That's right. The slopes are equal. How about the y-intercepts? Look at that. They are also equal. So if the slopes are equal and the y-intercepts are also equal, then this system has infinitely many solutions. There you go. Okay, so basically that's just the introduction of systems of linear equations. In the next video that I will create, I will discuss the solving part of systems of linear equation, that's substitution method, elimination method, and the one that has 3 variables. Okay, so thank you for watching.